beam span table is number 1. So we're just going to go through all of these numbers here to make sure that we're good with that. It'd be a good video for review again. Just going to find a pen here. So we're going to start off by doing one right here. Okay, so the building is 24 by 48. We have a nice drawing there to kind of help explain that. So the beam is running parallel to the 48-foot side. Basically, we're given a couple of options here to look at what might be best for this building to minimize the number of posts. So it's allowing us to play with different sizes. So kind of the first thing we have to do there is maybe get our supported length. So to get our supported length, we have to take the width of the building and then divide it by 2. So the width of the building is 24 feet. Right? So the floor joist will be going from here to here. So that's where our support length comes from the width. So 24 divided by 2 is 12. Okay. And then we have to go into the span book to find out the max span of a 5 2 by 8 beam for a 2-story house. Okay. So like all the assignments, spruce pine fir number 1, number 2 is kind of going to be what we're going with there. So we have to recognize that. We have to recognize the 2-story house and supported length. So I'll grab my span book here. I'm going to go to built up floor beams supporting 2 floors, right? So there's 1 floor, so it's a 2-story house, so we got to find supporting 2 floors. So built up floor beams supporting 2 floors of the house, that's Douglas fir, then it's hem fir below that, then we see spruce pine fir. Okay, so that's for 5 2 by 8s, which will be right down here. Okay. So again, always check the key items there. So built up floor beam supporting 2 floors, spruce pine fir, number 1, number 2. Our supported length is 12 feet, so we go under 12 feet till we see 5 2 by 8. So go all the way to the end. So 8'4". So we're going to write down 8'4" right here. And then from there, we're going to look at to see how many posts we'd have if we had posts spaced about 8'4" on center along that building. Okay, so kind of the first thing we have to do there is try to determine the number of spaces. The way we would do that is we take the length of the building and then we divide it by our max span, which we just found out. So in this case, we would take the 48 feet, which is the length of the building or the beam, and then we divide that by the max span, which is 8'4". So 8'4" in decimal form, right? So we're going to have to go 4 divided by 12. And we could see there 0.333, right? So it's going to be 8.33 as our divider. 48 divided by 8.333 gives us 5.76 spaces, so I'm probably going to round that up and say that it's 6 spaces, which would mean that there would be 5 posts. So I'm going to go ahead and now check that. I kind of step 2 there is to check that to see if it actually works. So how do we check that? We're basically trying to find the on-center spacing. The on-center spacing is going to be taking the length of the building and divided by the number of spaces now. So 48 feet divided by, we think, 6 spaces. So 48 divided by 6 gives us 8 feet exactly as a non-center spacing. But we then have to remove 6 inches off of that, right? So we take away 6 inches as a rule of thumb to then get the approximate clear span. So I'll just write down approximate clear span here. So we take the on-center spacing and then we subtract 6 inches. So on-center spacing is 8 feet. We take away 6 inches. That leaves us with 7'6". So that's kind of the number we're trying to work with. So basically, if we had 6 spaces, 5 posts. So maybe if I grab a scrap piece of paper here. Rather than draw on that right away there, I think I'll just do a quick little sketch here. So basically, if I have thickness there for foundation wall, so whenever we have the on-center spacing, we have the distance from outside of foundation to the center of a column. I'm just going to draw in a couple columns there. But I have the distance, on-center spacing is outside of foundation to the center of the column. Right, so when we did the math for that, we had 8 feet. But whenever we look in the span book for max spans, they're clear spans in between supports. So then the number would actually be from here to here. Okay? So that's why we took away 6 inches. So we took the on-center spacing, removed 6 inches, which gives us an approximate clear span. Not a perfect number there, but a ballpark to see if that's going to work for our building. Okay? So that's basically the clear span there. And then that is the on-center spacing. 2 different things altogether. So we got to make sure we take away 6 inches. So as a rule of thumb, we remove 6 inches off of this number to allow for about 3 inches there and about 3 inches there on average. And that gives us a 7'6" approximate clear span. Okay? So we kind of go back to the sheet there now. That's kind of what we're dealing with there. So basically the building, if we had 5 posts, there'd be a distance in between the posts of 7'6". The beam is strong enough to go 8'4". So there's a possibility that we could get this number closer to that number. So the strength of the beam is 8'4". We only require to span 7'6", so it's overkill. So we could go with the second option there. So the second option would be dividing by 5 here. So I'm just going to kind of throw that right here as a second option. That's option 1. Option 2 is dividing by 5. So basically removing a space, which will then make the other spaces larger, which may make this number closer to that number. Okay? So if I go 48 divided by 5, I end up with 9.6 feet here. Okay, and let me just throw a line through here, just so I can kind of keep that separated a little bit, which then is going to be equal to 9 foot. So I'm just going to subtract the 9 out of the calculator there. That's decimal feet, so I'll multiply by 12. That gives me 7 inches minus the 7, then times 16 to get the fraction. That's my numerator, so 3/16. So 9'7" and 3/16. Okay. So when I come down here, I then have to take off the 6 inches, right? So 9'7" and 3/16 minus 6 inches will give us 9'1" and 3/16. So will that work? So basically what this is saying is if I go with 5 spaces, 4 posts, the space in between the posts is going to be 9'1" and 3/16. This beam is only strong enough to go 8'4", so that won't work. So option 2, if you will, won't work. I have to go with option 1, which means I have 6 spaces, 5 posts, right? So 6 spaces, 5 posts. So I got to write down 5 posts here. So make sure you're not writing down the number of spaces here. I want the number of posts. Then what we're going to do is we're going to say if we have 6 spaces, 5 posts, the approximate clear span, right? Clear span is 7'6". I want 2 answers there. And then the last thing we have to do is find the bearing. So back into the span book, go to the end of built-up beams, which is 405-ish, 406, I guess. And then if we have a look at what's written down there, okay? So it's a 2-story house. We're going to make sure we're following. So beams supporting 2 floors. So it says 3-ply beams. We have a 5-ply. So that doesn't really apply to us, the first little sentence there. And then it says 4 and 5 ply, so that's talking about us potentially. With supported length greater than 10 feet, so our supported length is greater than 10, we have 12, is 4.5. So that's a sentence that applies to us. 4 and 5 ply beams with supported length greater than 10 feet require 4.5. So that's exactly what we're dealing with. So there's our answer, 4.5 inches. Okay. So then what I'm going to do is I'm going to kind of skip that, jump down to the bottom. I suggested that in class, right? To force yourself to kind of stop your brain and kind of reset and re-navigate the book. You jump from here to here, then back to this one, then back to this one, then back to the third one, and then back to the last one at the bottom. It'll force you to work through that book, making it better for you to learn, okay? So if we come down to the bottom, we're now dealing with a building that's 52 feet by 32. So our supported length is coming off of the 32. Right, so if we go 32 feet divided by 2, we end up with 16 feet. So don't forget your units there. There's a lot of people on assignments miss units. Make sure you write those down. Next thing we're going to do here is we're going to go ahead and find the max span for 4 2x8s for a one-story building. Okay, so now we're going to a one-story building. Let's throw this a little higher here so we can actually see. See the chart. So I'm going to flip to ahead a bit until I get to supporting one floor in a house. So it needs to be a 2x8. That's 2x10, 2x12. So here we are right there. So built-up floor beam supporting one floor, spruce pine fir, number 1, number 2. Our supported length is now 16 feet, so we're kind of following 16 feet. Sometimes a ruler or a pen there kind of helps to kind of line that stuff up. And then we're looking at 4 ply 2x8. Right, 4 ply 2x8, so we go under 4 ply 2x8 until we see 8'8". Okay, so 4 ply 2x8 is 8'8". So I'll write 8'8" on this side here. And then we're starting to look at figuring out the number of spaces. All right, so to get the number of spaces, I'm not going to write everything out in full there, but I'm going to take the length of the building, right? So that's kind of what we're dealing with there. We know the beam will span 8'8", so you want to find out how many times does 8'8" go into 52. Right, so 52 is the length of the beam. 8'8" is the allowed space between supports. So we want to find out how many spaces we'll have in that building. So if we go 52, length of building, right? And then we divide that by 8'8", which is 8.67 feet. Right, so if I go 8 divided by 12, I get 0.67, or 666 repeating. So if I go 52 divided by 8.67, I get 5.99 spaces. So you could basically say that that's 6. So 6 spaces, 5 posts. More than likely will work. We're still going to double check that, but so step 2 is checking. So checking maybe option A, okay? So I get the on-center spacing by taking the length of the building, and I divide that by the number of spaces. So the length of the building is 52 feet, divided by 6 spaces. 52 divided by 6 gives me 8.66 repeating feet, which is basically 8'8". Kind of the same number we kind of just worked with. That's the on-center spacing though, right? So we still have to take away 6 inches there. So basically, to get the approximate clear span, we take the on-center spacing and subtract 6 inches. So 8'8" minus 6 inches gives us 8'2". So being strong enough to go 8'8", we only require it to go 8'2", so that will work. Pretty close. Probably not going to find a better option there. But we'll just try a second option. So that would be option 1 there, by dividing by 6. So if I want to make that number bigger, which is kind of what I would have to do, I'd have to divide by 5 instead. Okay, so if I divide 52 by 5, I end up with 10.4 feet, which is 10 foot. We'll just minus the 10 there, times that by 12, gives me 10 foot 4. Multiply that by 16. So that gives me 12 16ths, but that's 5 or higher, so I gotta make that 13 16ths. Okay. And then from there, the next step is taking away 6 inches off of that, right? For the number at the bottom there, which is our approximate clear span. So that's our on-center spacing, 10 foot 4 and 13 16ths. 6 inches away from that's going to give us 9 foot 10 and 13 16ths. 4 from there and then 2 from the next foot. Now, will that work? So that won't work now, right? So now it's saying if I went with 5 spaces, which would be 4 posts, I would have a space in between of 9 foot 10 and 13, 9 foot 10 and 13 16ths. But the beam there is only strong enough to go 8 foot 8. So I got to stick with my original one, which I assumed was going to be correct. So I'm going to go ahead and go with 6 spaces, 5 posts. So I'm going to write down 5 posts here. And then I'm going to write down what the clear span is going to be for that. It's actually going to be 8 foot 2 as an approximate, without all the information needed. And the last thing we need there is to go get that bearing. Okay. So where's the bearing again? Bearing's at the end of built-up floor beams, which is on page 406 of this edition. So here's right there. So we're dealing with 1 story, right? So now it's a 1-story building. So always try to retrack what you're doing, right? This question here, it's a 1-story. Support length is 16 feet. You want to find the bearing for that. So beams supporting 1 floor. So it says 3-ply beams, we're 4-ply. So that doesn't really apply to us. But it says 3-ply beams with supported length greater than 14 feet require 4.5. So that's not ours. All other beams require 3-inch bearing. So that's where we are. A 3-inch bearing there. Okay. Let's go back up now. We'll do one at the top. Now that we have this math done here, we can almost help ourselves by reusing that. Okay. So I'm going to write down 12 feet here. I got to go get the max span. So 4 2x10s. So it's a 2-story. Built-up floor beam supporting 2 floors. And it's a 2x10s. Yeah, so I think we're in the right spot here. So built-up floor beam supporting 2 floors. Spruce pine fir, number 1, number 2, with a 12-foot supported length for 4 2x10s. We see 9 foot 1 there. Okay, so 9 foot 1. Now we can kind of, we could go back and kind of do the same formula here again, right? Which probably you probably should. So I'm just going to grab a scrap piece of paper for that. And so for this question here, kind of the first step we'd have to do is trying to find the number of spaces. Right, so if I take the length of the building, which is 48 feet, divide that by 9 point something, right? It's 9 foot 1. So if I go 1 divided by 12, it's going to tell me with the decimal, which is 0.08 feet. So now I can go ahead and find a number of spaces. So 48 divided by 9.08, that gives me 5.286 spaces. So we'll probably say, we'll round down there and say 5 spaces, which would then mean 4 posts. Okay, so that doesn't mean we're done there. We're going to check that. And we kind of already have the numbers. That's kind of what I was saying, right? So if I went with 5 spaces, I already have the math here. If I have 6 spaces, I already have the math here. So basically, the check would be then going 48 divided by 5. Well, I already have that. So the answer for 5 spaces for an approximate clear span would be 9 foot 1 and 3/16. That's what we would get for an approximate clear span. Will that work? The beam is strong enough to go 9 foot 1. The building will be 9 foot 1 and 3/16 as an approximate. So it could be more than that, right? Because we're just fudging the number. We're just giving a 6 as a variable. So it's not going to work, right? So even if it was correct, it's 3/16 more. So the code says the max span for a 4 2x10 beam is 9 foot 1. The building requires that space to be 9 foot 1 and 3/16. So it's not a lot. It's only 3/16, but it's 3/16. Right? 1/16 more is wrong. We can't, we're not an engineer, right? We can't say that that would be okay. So that won't work, right? So 5 spaces won't work. We'd have to go with 6 spaces and 5 posts. Is it overkill? It's overkill. That's not always a bad thing. So 5 spaces, 4 posts won't work. We got to stick with almost the same thing. So if I went with 5 posts again, and this would still be 7'6". That doesn't change, right? So we're dealing with 6 spaces, 5 posts, which is an approximate clear span of 7'6". So basically what that's saying is you'd be crazy to go 4 2x10s. Why not install 5 2x8s? That'll give you more headroom, okay? And you're going to still achieve the same number of posts in the basement. If you're the type of person that likes to overkill stuff, make it a little bit stronger, maybe then going to the 2x10 might be a good option. You don't want a bouncy floor, you don't want cracks on tiles, that kind of thing. But if you're looking at not spending a lot of money, not wasting headroom in a basement, maybe the 2x8 is the best option there, because you're not gaining any more living space by reducing a post, okay? So let's get the bearing for that, and then we'll move on. So bearings on 406. So again, it's we're dealing with a 2-story building again, right? So beams supporting 2 floors. So always look, right? Don't guess. Beams supporting 2 floors. It says 3-ply. No, we're 4-ply. Require 4.5-inch bearing. So then it says 4 and 5-ply beams with a supported length greater than 10 feet require 4.5. So that's what we are. That's exactly what applies to us. So again, it's 4.5. They're not all the same. Check every one of them, okay? Never guess. Never guess. Always check. So now we jump down to the bottom again. So down at the bottom again, we're dealing with a building that's 52 by 32. It's a 1-story. So we'll get the supported length there. And then we'll go ahead and get the max span for 3 2x10s. So bring the book back over. Built up floor beams. 1-story. There's 3, there's 2. We'll read all the headings again, make sure we're on the right page because they all look the same. So built up floor beam, 1 floor, spruce pine fir, number 1, number 2, and we're looking for 3 2x10s for a 16-foot supported length. Well, 16-foot supported length, 3 2x10s, I see 9'2" there. Okay. So 9'2" is what we have. And then what we're going to do is start working through the numbers again. Okay, so maybe that's, we'll kind of scratch that off, kind of work through some new numbers here. So I want to find the spaces, right? So number of spaces. So I'm going to take the 52 feet and I'm going to divide it by 9 point something. I'm going to take the 2, divide it by 12. That's going to be the equivalent of 9'2". So 9'2" is 9.17 feet basically, right? So if we're going to 2 decimals, that makes that a 7, okay? So then we'll put that into the calculator to figure out how many spaces we have there. So 52 divided by 9.17, that gives us 5.67 spaces. So it's more than 0.5, so I'd probably say 6 spaces. Round that up. Again, we always have to check it. That's 5 posts. We already have the math for that again, no? Right? So I already have the math. So we're assuming that it's going to be 6 spaces. So if we actually went 52 divided by 6, we get a on-center spacing of 8'8". If we took away 6 inches, we'd have 8'2" as an approximate clear span for this here. So we kind of already know that that's the clear span. Will that work? So what that's saying is the distance between the posts on the building is going to be 8'2". The beam is strong enough to go 9'2", so that's way overkill. So maybe there's a better option. We already did that, right? We already figured out the better option by dividing by 5. So if we divide by 5, we end up with 10'4" and 13/16. Okay, so that's the on-center spacing. We take away 6 inches. We then have, so that's this scenario. If we had 5 spaces, 4 post, can you still see that? Yeah. We end up with a clear span of 9 foot 10 and 13/16. So the building is going to have a gap between posts of 9 foot 10 and 13/16. The beam is only strong enough to go 9 foot 2. So again, that won't work. It's close, but it won't work. Okay? So that means we have to go with 6 spaces, 5 posts. So I'll put 5 posts here. Is it overkill? It is, but that's not always a bad thing. That's still 8 foot 2. That doesn't change. And then we'll check our bearing. Okay? So to get our bearing, back to 406. We'll read through that. Make sure we're good with that. So again, it's a 1-story, so we're looking at beam supporting 1 floor. Now we have a 3-ply, so beam supporting 1 floor, 3-ply beam with supported length greater than 14 feet. Our supported length is 16, so we're greater. Requires 4.5. So that applies exactly to us, right? 3-ply beam, supported length greater than 14 feet, require 4.5. All other beams require 3-inch. So that it's different, right? It's a change there because it's down to a 3-ply. Now we'll jump back up to the top there. I flip this paper over. So back up to the top, dealing with the 24 by 48 2-story house. Supported length is still 12 feet. Now we're going to find out what 3 2x12s have for a max span on a 2-story building. Okay, so we go to the 2-story building now. So see how I'm flipping back and forth there, making my life hard, but that's the way you learn, right? When things are hard, you learn. You play around in the book a bit, and then you get where you need to. So built-up floor beam, supporting 2 floors because it's a 2-story house, and we're looking at 3 2x12s. So spruce pine fir, number 1, number 2, supported length of 12 feet, and we go down to the 3 2x12, which is 9 foot 2. So now we're at 9 foot 2 there. So the max span's a little bit bigger, which is going to help us. Okay. So if we work through the math here, it'd be very similar to the one we just did actually. Right, 9 foot 1 or 9 foot 2, it's pretty close. So I just maybe flip that paper back over actually. So you can see here we went 48 divided by 9.08. Well, 9.2 is actually 9.17, so it wouldn't really change the answer a whole lot. Right, so 48 divided by 9.17, which is equal to 9 foot 2, gives us 5.23 spaces. So we'd probably still stick with 5 spaces, which then would give us an approximate clear span of 9 foot 1 and 3/16. So will that work? Now the beam's strong enough to go 9 foot 2. The post spacing on the building itself is only going to be 9 foot 1 and 3/16, right? So that'll work. Just work. Maybe you're playing with fire there, right? Because again, we don't know all the specifics of it, but it will work. So if we're kind of going by our rule of thumb being 6 inches being correct, this will work. Okay? So basically what that means is we could write 4 posts here. We could write down that we have a approximate clear span of 9 foot 1 and 3/16. Before I actually did this, I'd want to make sure what size post am I going with? What is my bearing? In case that number changes a little bit. Okay, more than likely it would actually be smaller, I think in this case, because of the bearing. So we should be okay, but not always a bad idea to maybe go to 4 2x12s or something like that, right? So by basically going with 2x12s, we reduce our headroom in our basement, but then we minimize the post. Right? So it depends on what the homeowners want, right? Are they using that basement, or is it going to be just storage? Then it doesn't matter. Then maybe even why bother removing a post? But so it's just those kind of things that that you have to look at, which could be options for homeowners. Okay, so if we then go find our bearing on 406, just to finish that one off. So again, we're dealing with 2 stories, so beams supporting 2 floors. 3 ply beams require 4.5, so that's what we have there, right? 3 ply beam on a 2-story building, so built up floor beam, beam supporting 2 floors, 3 plies require 4.5. There it is, done. So it's a different sentence, but it ends up with the same bearing, okay? So we'll finish off by doing the bottom one there, so 16 feet. Let's find 5 2x12s for a 1-story building. Let's go to a 1-story supporting 1 floor. So built up floor, beams supporting 1 floor, spruce pine fir number 1, number 2. We're under a 16-foot supported length now, and we're looking at 5 all the way to the end, 13 foot 8, 5 2x12s, which gives us a max span of 13 foot 8 inches. So now we've jumped up quite a bit there. That should make a big difference, right? That's kind of what you want, right? You don't want to do little increments. You want to do a big jump there to make a difference, to be able to possibly remove a post. So if we're trying to find a number of spaces there now, make sure this is kind of, if we're trying to find a number of spaces, we're going to take that 52 feet, which is the length of the building, and we're going to divide it by the max span, which is 13.67. And that'll give us our spaces there. So if we go 52 divided by, can you still see that? Yeah, 13.67. It gives us 3.8 spaces. So we're going to say 4 spaces, which would mean 3 posts. Is that a done deal? Nope, we still have to check it. So we're going to go ahead and we're going to check that. So option 1 there is basically getting the on-center spacing. Step 1 is, so we'll go 52 divided by 4 spaces. Gives us 13 feet as an on-center spacing. And then you get the approximate clear span. We're gonna go basically the 13 feet minus the 6 inches. So 12 foot 6 is what we're dealing with, okay? So if we had 4 spaces, 3 posts, that means we'd have a gap between the post of 12 foot 6. The beam is strong enough to go 13 foot 8, so there could be a better possibility there by doing option 2. So let's try option 2 here by dividing it by 3 instead. So it'd be 3 spaces, 2 posts. That's probably extreme, but let's check it. You never know. So let's go 52 now, divided by 3. So we end up with 17.33 feet, which is 17 foot 4. So if I subtract the 17 there, that's feet. So I multiply that by 12 to put it into inches. It gives me 4 inches exactly. Then I'd have to remove 6 inches off of that to get our clear span, which would give us 16 foot 10. So that's way too high, right? That won't work. So we have to go with option 1 there of 4 spaces, 3 posts, which gives us a clear span of 12 foot 6. And that's pretty well done there. We just need to get the bearing. So go to the end of your built-up beams. So there we are right there. So again, it's a 1-story building, so we're looking under beams supporting 1 floor. 3-ply beams with supported length greater than 14 feet require 4.5. That doesn't apply to us. Therefore, all other beams are 3 inches. So there it is. Okay? So that's it.